Take two. Right, we are finishing trip today. We are about 2-3 weeks behind, okay? So we are probably have to do part of your travelling course and your HSC course. Alright, we'll see how the next couple of topics go in terms of how much work we're getting done. But there is a new topic that we were going to do, I was going to do, but I didn't expect, I was still doing trigs, because that was only 2 weeks worth. But I'll be doing that at the start of term 3. So you're looking at you're looking at functions and graphs. So we started looking at it in terms of defining a function. You'll then continue on that work, and most of it is pretty much graphing all your linear and non-linear relationships, okay? So that will be that. I'll start it, and then you'll have to continue it when I'm not here. Right, so the last thing we were doing is on page 53. We were looking at 2 ships that was leaving at point P at port. Okay, so we've got some rulers and drawing up some diagrams.
Will that be uploaded, the video from yesterday?
Yep, so this afternoon I'll upload everything that hadn't been uploaded.
I probably won't understand what you're about.
That will probably be a good idea. Okay, so we are, yesterday we finished off the sine cosine rule, okay, for non-right angled triangles, and we started looking at applications. So most of your application will come in these styles of questions that we've been doing. Okay, lots of bearing questions that will also incorporate non-right angled triangles, and you will have to do some maths in terms of finding some distances and sides. So ship A travels 12 kilometres per hour on a bearing of 213. What happened to one I gave you?
I just threw all the stuff in my bag.
I thought you were about to say I just threw my ruler out.
No, because I don't.
That wouldn't have made me happy at all.
Because I was away on the weekend, and this morning I just threw
okay, so we have ship A on a bearing of 213. So we have 33 degrees here, and ship B, which was on a southeast direction. So you need to know where north, south, east and west are in the diagram. So I'm just redrawing the diagram so I can help with my reference of the question. And we worked out that this is 36 kilometres and this is 24 kilometres. So I'll make this a bit shorter, just relatively, so that it will hopefully come up to a more accurate representation for our answer. So we first labelled and drew and labelled the diagram, and the last thing we did was we found the distance between those 2 ships, correct?
Yep.
Alright, so this is ship A after 3 hours, this is ship B after 3 hours. So this was the cosine rule, so we knew the 2 sides and the included angle, and that's the criteria for your cosine rule. Right. So what was the distance between them? 89?
No, 39.
Okay, so we also talked about this because there was no rounding given in the question. However, on practical style questions like this, everything is in whole numbers. So that means you can answer to whole numbers. But you need to make a reference to that, so to the nearest whole number as part of your final answer. Right. So the final question was, calculate the bearing of ship A from ship B. So remember, the word from is your location and your starting point. So the first thing you would draw is a compass on B. Always showing where true north is, so directly up the page. So we need to find the bearing of ship A from ship B. In other words, we need to calculate that angle through that way. Or we can calculate the angle back through this way. Right, how am I going to do it?
Alternate angles on parallel lines.
Mm-hmm.
45 degrees.
Yes. Right, so because of the 2 compass, they're going to be parallel when I put the transversal. There's my Z shape. That means this angle here is 45 degrees. Okay, that's a start. It's not finished though. What else can I do? Sorry? Yep, okay. Alright, so the other side there is 45. However, it doesn't give me that little bit in there. So what else can I do?
Could you put a compass on A?
But you will have to know the angles in there either. Okay, so I need this little bit here, correct? Alright? In other words, I need this whole angle here, correct? So what am I going to do? Sine, okay? You can use the cosine rule because you know three sides, okay? Or you use the sine rule because you know, you can't use sine also because you don't know two angles, you only know one. So yes, you'll actually use the cosine rule, okay? Because I know the three sides, but I only know one angle. Okay, so we need to find cos B. Who remembers the rule?
Oh, A squared plus B squared, take away 2AB.
No. A squared
Two-
plus
take
C
away
squared
2AC.
2AC.
It's AB, and then
Where do they go though?
78.
A squared plus C squared, take away
2AC.
Nope.
Oh, over 2AC.
Oh, okay.
Oh,
Take away B squared.
Good.
That's it. I was thinking the other one.
Yes. Okay, and remember this is a rearrangement of the c squared equals a squared plus b squared take away 2ab cos c. Alright, so you need to remember them or you need to be able to derive them. Alright, I would work on remembering them. Okay, and that's why when you go through exercises you will rewrite that formula every single time and that will help you to remember it. Alright, so b is going to be cos inverse of everything on that side. This is technically p, but you don't really have to reflect it in your formula as long as the numbers are in the right spot. Alright, so this is A, opposite A, and this is B, opposite capital B, sorry. And this is technically P, this is opposite port, where we started. However, in this context, it'll be our C. Okay, so you can either make that C a P, alright, or use that and label it C. Alright, A squared, so 24 squared plus 39 squared, take away 36 squared over 2 times 24 times 39. Okay, make sure that's in a bracket because you're taking the cos inverse of everything on the other side. Alright, so again, no reference to the rounding, however, we will do some nearest whole number because everything else is also to a whole number. And make sure these calculators are set to degree mode. If you have them in radian or gradient mode, you will not get the correct answers.
4.6661.
Do we agree? 65?
To the nearest whole number.
Yep. Make sure you write that in your answer. Bo and Emily, we agree with 65? Alright, so next to it, in bracket, nearest whole number, which bearings are typically, but you can have the point something in a bearing. Alright, however, I would not imagine you will see any of those. Alright, so that angle in there is 65 degrees. So what is the bearing of B from A? What is the bearing of A from B? What's the maths?
360 take away 65 plus 1.
Okay, so I'll go start from this. I'm going in anti-clockwise direction. So I need to do 360. Take away that 45 that we've already established. Please write these things in your diagram. That will help your marker to see and gauge whether you understood part of the question. Alright, take away that 45 and then you need to take away that 65 to get to that line there. So 360 take away 110, so 250 degree from true north. Alright, remember the capital T, reference from true north. Okay, while it's not required, this question sometimes asks it, this question sometimes doesn't ask it. Okay, question. Right, so remember all your applications of your non-right angle triangles in particular. You can also have just simple right angle triangles as well in these styles of question, but I can almost guarantee in your HSC you'll have a similar style question like we've done today and the end of yesterday and the last one I'm about to do now. Alright, any questions before I do the last one? Right, so reading through these questions, make sure you read through the whole thing and then go back and construct a diagram. Alright, our ship is travelling in a direction of 065 degrees from true north. Observe 2 lighthouses due north. After travelling 4 kilometres, one of the lighthouses bears 285 degrees from true north and the other bears 315 degrees from true north. You need to calculate the distance between the two lighthouses correct to the nearest 100 metres. Okay, so now we've read through the question. Alright, so when you do a diagram, let's do a quick draft first and then we'll do a proper ruled up one. So a ship is travelling in a direction of 065 from true north. So let's start here. So 065 is somewhere off in that quadrant, in that direction. Doesn't need to be accurately 65 degrees. Okay, so no need to get your protractors out and get 65. I mean, you can if you want, but that's just not going to save you time down the track. Observes 2 lighthouses due north. Alright, so we're starting here. At the start point, we see those 2 lighthouses, something like that, due north. After travelling 4 kilometres. Alright, so the ship's travelled that 4 kilometres to that point on that bearing. One of the lighthouses bears an angle of 285 degrees from true north. Alright, so we've got this line here and that line there. Okay, which is reasonably accurate. So 285, which is just a little bit up from the west. So that's accurate there. And the other one bears 315. Alright, so we've got that whole angle is 315 degrees there. We need to calculate the distance. So that will be the distance between the 2 lighthouses, x there. So basically you're going to be using this triangle here, I would say. Yep, and that's why we get a nice big one to do the proper diagram with rulers, of course. Alright, make sure your diagram is at least a quarter to a third a page so that when you label information in it, it's not being squashed in. Alright, so now we're just reproducing that diagram, just making it more tidy. Alright, so we have lighthouse 1, lighthouse 2. Alright, so this is 65 degrees, make that 15, so 25. Alright, so that is 4 kilometres here. Right, so labeling your true north. There. Alright, so the first ship was a bearing of 285. So remember 90, 180, 270. That means that extra 15 degrees is from that horizontal up. And then this whole angle here is 315. So from the horizontal, it should be 315 take away 270, which is 45 degrees there, that whole angle. Alright, find the distance between two lighthouses, which is correct in the nearest 100 metres. What are we going to do?
Work out that little angle.
Sorry?
45 take away 18. Is that an 18?
15.
15. 45 take away 15 equals
Mhm.
the angle
Yep.
there.
Right, so 45 take away 15, so that means this angle here is 30 degrees. You can see why the diagrams need to be a bit of size, so you're not just squeezing stuff in. Right, you've got one angle in there. What else can we do? Not looking at your final product, you are looking at what else could you do for your diagram.
Oh, that little one. That little one in there is 25.
Which little one?
Between down over down. Oh, I think it's 25. But why?
Why is it 25? Oh, yep. Mm-hmm.
And then from that you can use the side rule. Then
Do we have enough information there?
Another side, don't
Or you can
Exactly.
get the angle for the other two angles from the,
Yeah, you can get the other angle from that because the angle's under the triangle.
and then
Yep.
the other angle of the supplementary,
Mm-hmm.
and then you have two angles, two of the angles for the triangle at the top.
Yep. Alright. So the alternate way that you could have done that, there was the horizontal there, we could have done alternate, so that would be 90 plus 15. There's the right angle there. That's 15 degrees there from the alternate angle. And then yes, you can do angle sum of your triangles. But how would I, now that we've seen that, how am I going to now approach the question? 105, 75, 30, and 90, 120, 135, 40, 45. Oh, that might help us.
You can work out that one using the side rule. You can work out L1
Mhm.
to the second little thing using the side rule curve.
Lots of numbers. However, we have all the angles inside the triangle, okay? So we have two angles on one side, we can use that to find another side. However, we need to find the distance from here to here, which is not the whole distance there, and the only other distance we're given is how far the ship has sailed. Okay, so basically you're going to have to do it twice. Alright, you need to use the bottom triangle to find either that side or that side. Okay, and then use that information to find the rest of it. So, I would do this one here because you need a side in this triangle. You have three angles. Once you calculate that side, you will then be able to use the sine rule again to be able to calculate the distance of that other side. So, call that x. That side x. So I know 4, the length 4, I know 75, I know the opposite angle, and there's my variable. So A over sine capital A is equal to B over sine capital B. So x is my variable, that's why it's on the top left, so it's easy to move, over sine of the opposite angle, sine 65 degrees, is equal to the side B.
I think he's looking for his quals.
Right, so 4 over the opposite angle, so sine 75. Alright, now this goes back to your rounding errors, okay? Do not round anything. I mean, yes, have an approximation, but do not round it. Alright? So, x is going to be 4 times sine 65, bring that up, all over sine 75, which equals what? The distance, 3.75.
3 1 1.
Right, dot, dot, dot. Okay, so let's show a couple more decimal places than what you required. Actually, the question said to the nearest 100 metres, so it's 0.1 of a kilometre. So you actually need at least 3 decimal places here. Right, so 3.75, 3, dot, dot, dot. Okay. Now, I showed you how to store things in a past lesson, so that's probably a useful application for that. So shift and store, and then choose the letter. Okay, it was on a past video for those people that were away. So that's that distance there. So we need this distance, we know the opposite side, and now we have a known angle and a known side. So then we use the sine rule again. So therefore D over, you don't have to write the formula again, you've already written it down for this question. So we're looking for D over sine 30, the opposite angles, that little bit there is 30 degrees for that triangle there. Alright, which equals this answer, so 3.753 dot dot dot. So show that you are not rounding, you're just writing the first couple of decimal places and showing there's more to it. Over, so that was that side, over sine 45. So, this question you don't have to do the following, however, we have done lessons on exact ratios. So we a half times 3.753 dot 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 all over 1 on root 2. Alright, so they need an exact value for the answer for this, that is what you need to do. However, the question is not requiring us to do that, so we can just put in sine 30 and sine 45 in the calculation, rather than half and 1 over root 2. Alright, so the nearest 100 metres, so we have distances in kilometres, so 100 metres is 1/10 of a kilometre, so we point one decimal place, sorry. 2.65 dot dot dot, so 2.7. Do we agree? Don't forget your units. 2.7 kilometres. Right, so the questions can be difficult. Start drawing diagrams, start labelling stuff like we've done there, and then hopefully you will see an application where you can use your sine rule or cosine rule to be able to make some progress and hopefully answer the question. Right. Did everyone somewhat follow that? Any questions before I move on to the last section? Something nice and simple to finish with. Okay, so the last section. Last section is area. On page 53. Okay, so the area of any non-right angled triangle is a half AB sine of the included angle. Okay, half times A times B times 2 of the adjacent sides multiplied by the included angle. Alright, proof 6.3. B, C, A, C, B, A, and drop that perpendicular down to the right angles. We'll call that H. Alright, so how do you know how to calculate the area of a triangle?
Half.
Area of a triangle.
Half times base times height.
Okay, triangle half a rectangle, half a parallelogram. Okay, so area is a half base height. So it's a half, that's the formula. Half times the base, which is A, and times the height, the perpendicular height, which is H. Okay? So, what else could I label?
90 degrees. No.
Sorry?
You've already done it. I was going to say the 90 degrees, but you already did it.
Yep, what else could I write down? What's another equation I could write down? Something we've done before.
C squared equals... No.
No, not that information's not necessary. What's the other thing that I did?
Sine,
Good. Not sine rule though.
cosine.
No. What's sine C?
A squared plus...
Cos. C 95
No, 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 no.
No, we've done this before.
Yeah, we
That's
have.
Something over something.
Yeah, what is that something over something? What's the ratio for sine?
over.
C.
I over H. So,
Oh,
opposite.
wow.
You like making things much more difficult than what it needs to be.
That's embarrassing.
Okay, so rearrange the equation and get H the subject. And now we simply substitute in for H for U. Equation 1, equation 2. So equation 2 into equation 1. We have the area, which is a half A, B sine C. There you go. Probably wanting more simple proofs this topic. Okay, so again, you are not required to know the proof. However, you are expected to know to be able to apply it to question. Okay, let's find the area, correct to one decimal place. In your note, it says find the length A in A, correct to 2 decimal places, cross that off. Obviously forgot to change that when I copied the formatting. So we need to find the area, correct to 1 decimal place. And I'll start at K, not J. Alright, so example. Alright, so it started with a J, okay, but the last question was a J, so we'll call this K. Okay. Right, so what do we have? 10 centimetres, 100 degrees. We have 4 centimetres, D, E, and F. So, when you have two sides in the included angle, you can use your area of a triangle using the sine rule. Okay, the area.
Okay, so can I ask you something, please?
Is it relevant?
Yes, it's maths and area stuff. If the perimeter of a rectangle is the same size as the circumference of a circle,
Yeah.
why is the circle's area bigger?
Because the circle will always be an approximation. Because of pi. That's your short answer. Okay, so when you have two sides and the included angle, half times 10 times 4 times sine of 100 degrees. So 20 times sine 100 equals what? 2, 1 decimal place, please. Alright, and don't forget area, you need your unit and you need your squared units. Do we agree? Someone else put in their calculator? I'm just going to trust Nicola, she's always got the correct answer. Not necessarily.
The circle's area would be larger. With the exact same strength, the area would be larger.
Alright,
It'd be larger.
good.
It's larger
Al,
by 27.7.
last question in this topic. Whether you're happy or sad about that. But your extension students don't need to be sad for long because you're about to do the extension component of it. Alright, 21, 18, 45.6 degrees, 83.6 degrees. B, C, A. Alright, so what's my next line going to look like?
Times it. 180 take it out.
50.8.
Is what?
The C, like the degree for C,
Yeah.
it's 50.8.
So half times 18 times 21
Right, so remember it is two sides and the included angle, okay? Not two sides and any other angle, okay? It needs to be two sides and the included angle, right? So you are given the other two, you have to do simple angle sum of a triangle formula, of your angle sum of triangle formula. So half times 21 times 18 times sine of 50.8.
146. 5.5.
146.5. Verification. Yep. Alright, so what are my units?
7.
Well, there's nothing given to you in here. Okay. So you need units. Grip. Okay. It means to make sure you include that for if the units are not given to you. Alright, so that covers up to and including 613. However, you mathematics students, you are not required to do... Hang on, that is everything. Nice extension starts after that. Alright, so exercise up to and including 613 can now be done. Alright, so I've already told you that this will be due after the holiday. Alright, because I won't have a chance to check it before I go. So I'll be leaving on Friday week and you won't see me until next term. Start of next term. Alright? So that means...
When can we play poker?
Hey?
When can we play poker?
When I'll find out when Miss Smith comes back. Okay? So we'll be starting trig for extension tomorrow morning. Alright, so your first lesson back. Okay, you need to have everything in chapters 4 and 6 completed and handed in. Okay, so pardon? We are going to do 5. Start chapter 5 on Thursday, and that will probably be a week or two after you'll come back. Okay, so it gives you a chance to make sure everything's done, and give me a chance to actually sit down and have a look. Right, any questions on anything in the topic?